Hello, hello, everyone. Hi. We are live. Okay. Let's see. Let me just join the chat real quick. Okay. Let's get started. So, hello, everyone. My name is Niels Ben-Thielen. I'm the Chief ML Engineer at Union.ai. And I'm super excited today to walk through this workshop with you. This workshop will not go too deep into deep learning or LLMs or into the weeds of RAG, although we will today build and run a RAG system on Union. The focus today is to get an overview of how RAG works, all the pieces. Hi, Charles. All the pieces that you need to get it working. But the focus is to understand what it takes to put such a system into production. And today's focus will be kind of less on the real-time chat app type system, although we will demo something that looks like this. We'll focus more on the RAG application itself in more of a higher latency context. So if you can wait 30 seconds or a minute or a little bit more for a response from your RAG system, then this is something we'll build and run today. Just before I get started, just wanted to loosen up the chat a little bit. If you can quickly just say hi, say what your title is, if you're a data scientist or ML practitioner, where you're working right now, or what kinds of projects you're currently working on. It's a good place to just get the chat going. All right, so I will share this link now. This is a repo that's open source, and it contains a notebook that we'll be using to run this workshop. So I'll punch it into chat just now, so you can start poking around in there. 1 second. Okay, very strange. My chat comments are not going through, but hopefully you can go scroll up a little bit. There should be a message for the GitHub repo, github.com/unionAIOSS/unionRag, and there should be a workshop.markdown file. Okay, so just first things first, this workshop will run about 45 to 50 minutes. You can pepper me with questions throughout in the chat. I will be sharing a OpenAI key in the Slack channel that we're going to run this workshop on. Don't get too excited. It has a $10 spending limit, and I will delete the key after this workshop. So if you're thinking you can run off and run a bunch of jobs on this key, then you're out of luck. But we're going to use this key just so everyone has an open AI key. Hi, everyone, as you stream in. Welcome, welcome. So the first things first, you can reach this page here quickly if you're not already on there. So it's kind of a short link to this README page. You can join the Slack channel. We're going to use Flyte Slack, so you can join with whatever account you want, and you will end up in the right channel. So once you join, you can click on this link to go to the right channel. And let me just show you what that looks like. So you'll end up over at the LLM RAG Workshop June 2024 channel. I'll be sharing the credentials here. And just as a point of order, if you have any technical issues, troubleshooting, there will be some folks in this channel from our team to help you out. So if you have trouble signing in or making an account, or if you see a bug, that is unintended that you come across in the workshop, please post a message up here and someone will get to you. Okie dokie. So as a brief outline, what we'll cover in this workshop, first we're going to set up a Union AI account. A Union serverless account is something we kind of launched recently. So Union serverless is our offering for Union, which is an AI orchestration tool. And we're going to dive into how we actually make tasks and workflows and complex AI-related workflows here. We are going to launch a RAG workflow using Flyte, LangChain, and GPT, and Ollama, actually. So just for some background, Flyte is an open source orchestration tool that we help to maintain and build up. So that is our open source project, and Union is our the platform that commercial platform we've built on top of Flyte. So you'll get a better sense of this, but maybe, yeah, if you consider the vector space of orchestrators, there's Airflow, there's Prefect, there's Dagster, and in that similar area in the vector space, you have Flyte. We will interact with a Union serverless workflow through a Streamlit app. This will be kind of a chat-like interface, which is admittedly not the best interface to interact with this, but it gives you a good sense of how to work with your RAG application. And then we are finally going to refactor our RAG workflow to use OpenWeight's LLMs. And we're going to do this with Ollama, which is a cool open source project. If you're not aware of it, you can find it over here. But essentially, it's a way for you to serve on your local machine or on some node somewhere in the cloud, perhaps, serve a lot of the LLMs that are open weights, but then you can also build your own, fine-tune your own, and it kind of makes it easy to import these. So hopefully this outline makes sense. And without further ado, let's click into this Open in Colab button, and it should take you to a Colab notebook that looks like this. The first thing you're going to do is you're going to sign up for a Union serverless account with this extra little query parameter here to say that you are part of this workshop. It's going to take you through a whole GitHub sign-up flow. I already have an account, so this will actually just take me straight to the dashboard. There will be a few more things that you'll have to click through to give permissions and whatnot to your GitHub account. But hopefully, you may have to refresh the page a few times, but hopefully you end up at the Union dashboard, which looks a little bit like this. We're going to be working with this dashboard throughout this workshop, so I won't spend too much time here right now. But as you can see, on the left-hand sidebar are all the different entities that Union knows about. Executions are when you run a workflow or task. Workflows are basically DAGs, and tasks are the steps in that DAG. Okay, so if you haven't gotten redirected, you may have to click on this link to go to the dashboard. And the first thing we'll do on this notebook is run this cell. All this does is it will clone the Union RAG repo, which is this repo right here on GitHub. and it'll install a bunch of requirements that we need to run stuff. It will actually override the versions of packages that are already installed in this Colab environment, so it'll ask you to restart the session. It might even do that automatically. So take a few minutes. Cool. While this is going, maybe I can just introduce you to some of the concepts here. So the first thing we're going to run is a workflow. So the workflows tab here, in my account, in my serverless account, I have a bunch of them since I use this product a lot. The first workflow we'll run is this hello world workflow. We're going to take a look at the code for that also. Okay, thanks, Charles, for the update on just pipping away. Okay, so let's just restart our session. It's all good. And then the next thing we'll do is hopefully you have a serverless account already. Please ping the channel if you don't. But then we're going to create a session here, a login session. So if you run this cell, we need to authenticate this Colab session and be able to connect to our account. So if you click on this URL, it's just to say authentication pending. So you click on this URL here. It's going to take you to this page to activate the device we're working with. And it should have the code already embedded in there. So now my account is activated on this Colab session. And you should see something that looks like login successful. You can now use Union.ai CLI. Great. So as a sanity check, let's run this hello world workflow that's over here. So maybe I can just show this real quick on the, actually, I'm going to use VS Code. So this is just my local VS Code editor. Hello world workflow, super simple. We're just defining a workflow called main, which is we're going to return a string, and it's just going to call a workflow called hello, or sorry, a task that's called hello. And the task itself is just going to turn the string world. There's a lot going on here under the hood, and I'll break this down when we get to the more complex RAG stuff. But if I pop back onto the Colab notebook, you should see a link here to the serverless URL. And this takes you straight to the execution page of the hello world workflow. Again, it's a DAG with just one node, not super interesting, but you can poke around here to get a sense of what the UI looks like. There's a list view for all the steps in your workflow that ran, a graph view just to see a little bit more of pretty format, a timeline view allowing you to kind of profile, how long each step took. We'll look at a better example than this later. Okay, last setup step is the setting up of our OpenAI secret key. So as I said, if you're not already in the Slack channel, please head over to slack.flyte.org and then go to this link. I'm in the workshop markdown file. I'll be posting up the key just now. If you have your own OpenAI key, please feel free to use it. Just didn't want folks to have to set up an account if they didn't already. So putting it up right now, you should see it. And what you're going to do is you're going to run this cell, Union.ai create secret OpenAI key. OpenAI _API _key. And what this will do, so I'll actually run through these steps. So I'm actually going to delete the key that I have already. And I'm going to run this. And it's going to open up this little input box. So just copy paste that in there. Oops. And now as a check to see whether that ran successfully, you can say Union.ai get secret. I have a bunch of other secrets in here, but you can see, you should be able to see an entry with this name. And if you have any trouble, for whatever reason, you can try deleting it and rerunning the cell above here. Okay. Yeah, you may have to, if you don't see any executions on the dashboard, you may have to run this cell, Union.ai run -- remote workshop / starter.py main. And that should run the execution. Okay. So just looking at the time here, we're doing good. The first thing we're going to do is run this cell because it's going to take about 7 to 8 minutes, and I'll explain why. But this is, I thought about pre-building an image for this workshop, but I did want to give you a sense that typically when you want to productionize something, you want to build a Docker or whatever other image, a container that packages up all the dependencies of your application. So let's go ahead and run this. And I'll explain what we're going to do, what it's doing. So when you run the cell, it's looking for an image that's not found, and so it's building the image. And this first URL you encounter after build submitted over here, this is actually a workflow that is running on serverless, Union serverless, that's building the image behind our application. I've pre-built this image here, so it ran super fast for me. It only took 8 seconds, but it'll take about 7 to 8 minutes, and that is because we have a bunch of dependencies in this application. And after the build of your image is complete, you should see a URL, oops, like this, which is the actual execution that we want to run. And while that's running, let me explain what we just ran. So as you can see, we have this langchain.py file, and we're running the create knowledge base execution on it. We're passing in 2 arguments, exclude parameters and limit. And I'll explain what those are in a sec. But while this runs, I want to take this opportunity to just go through a quick refresher on Retrieval Augmented Generation, or RAG. So a very simple version of RAG is basically this workflow. You start with a user query, and it could be, in this case, we're building a RAG application as a Flyte bot, customer service bot. So it should answer questions about Flyte. And the user query might be, what do I get out of Flyte? How is Flyte different from other orchestrators? Or you can ask it to write code for a specific, write code that trains a sklearn model or something like this. So you have a user query, then you have a knowledge base, and this knowledge base can be the Flyte documentation. So we have a bunch of documents on the web And we have to embed both. Well, to create the knowledge base in the first place, we need to embed the documents and throw them into a vector database. And a vector database you can think of as a regular database, except the kinds of queries you do with it are, let's say, vector first. And so vector is just a series of numbers, a list of numbers. And you can do things like similarity scores, cosine similarity between two vectors of the same size to get a smaller value, meaning they are more similar, or a larger value, meaning they are less similar. And this is the way we can query this database against a new user query. So if I say, how do I build images on Flyte? That text needs to be embedded, and then a query is run against the documents that we previously embedded. And this is our source of truth for, if you're taking an open book exam, these are the pages you flip through to answer the question that, the exam is asking you. So in this case, we retrieved some top K chunks of these documents from the vector database. We concatenate them with the original user query here and here in some way, which we'll see later. And then we feed that into some function. And today this is a LLM, large language model, which then produces a response to the original user query. Yes, Peter Shen, thanks for the question. What's missing in this step is basically another function, also typically an LLM, or it could be, I guess, a language model in general, like BERT, something that can take in text, encode it into some set of tokens. Tokens are just words or pieces of words, and then convert them into this list of numbers that is compatible with each other. So the embedding model you use to embed your documents should be the same embedding model you use to embed your user query to get the top K chunks. So I'll give you a better example of this with the open weights. Okay. So hopefully this is running for you now. Hopefully you see a link like this. So not to confuse these two links, this is the image building link. And this is the actual create knowledge base link. And so if I click to the create knowledge base link, I have here 2 steps in my workflow. One step to get the documents. And in this case, documents are, just to make it concrete, this is docs pages in our Flyte repo, or sorry, in our Flyte project. So these are all the user guides, so on and so forth, what Flyte is, how to use it, etc. So that's this step. And then we create a search index. And this is, if I hop back onto, if you recall, oops, this is basically just another name for vector database. Oops. If you look at the timeline view, I cache these 2, so these will be much longer for you if you're reconstituting or creating your knowledge base for the first time. And in this UI, there are some other things you can look at. So you can look at the inputs and outputs of each step. You can look at the inputs and outputs of the workflow overall. And now it's a good time to look at the code for this. So if you go back to the Union rag repo, the code for this is under the Union rag directory under this langchain.py file. So here it is. And I'll point your attention first to this create knowledge base workflow. So the way in Flyte is the SDK for Flyte, which is what Union uses to run these complex DAGs. It's just a function. It's a Python function. You decorate it with that workflow. And this is basically our DAG builder. It's kind of a subset of Python. We try our best to make it clear when you're kind of veering off of that subset of Python that this workflow DAG builder supports. But in the simple case, you're calling tasks in sequence. It takes in inputs that are strongly typed. So Flyte is a strongly typed orchestration tool. It understands the types, and we have this as a strong opinion because we can actually do a lot of things like compile your DAG and make sure all the types between all the different interconnected tasks are compatible. So if you recall, we put in exclude patterns and limit as our input back in our notebook. This just limits the number of documents to either all of the documents in the flyte.org doc site, if it's none, or if you specify an integer, it'll just ingest the first n documents that it finds. And exclude patterns, if you recall here, I'm just not ingesting any of the API reference or tags URLs. These are just like specific subpages that group tagged pages together. So not super informative when it comes to a Flyte assistant. So this workflow just calls these two tasks, get document and create search index in sequence. So let's take a look at what these tasks look like. So get documents, a task is also just a function. It's a Python function. Again, it is strongly, or it's typed, it's using type hints. And I don't want to get too bogged down by the details of the function itself. All you have to know is it downloads a bunch of documents from docs.flyte.org. I have a version here that also gets the Union docs, which is a kind of superset of Flyte with some differences. And then it will produce a list of custom documents. And this set of custom documents is just a data class that I've defined here that has a file path to a page and some metadata. And we can convert this to a LangChain document. So LangChain is the LLM pipeline tool that we're going to use to actually abstract away a lot of the details of a RAG pipeline. And it'll contain some page content. So this is the string markdown-like representation of the docs page with some metadata containing the URL. And I think URL is the main one. So, and actually we're going to define documents as a knowledge base. And what is this? We're using Python's typing annotated type to attach some extra metadata to this list of custom documents. So if you go up here, we're creating two artifacts. And artifacts are a way for Union to understand the outputs, the things that you produce from tasks in a first-class way such that I can reuse the artifact in different ways. And we'll see this later. But we're defining two. We're defining the raw knowledge base, just the raw collection of documents in text form. And then we're producing another artifact called vector store. And this is our vector DB. We're going to use FAISS, F-A-I-S-S. This is a Facebook produced, I think they created this vector in-memory vector store technology that we're just going to use. And you'll notice that this vector store artifact has a partition key for embedding type. And this is going to be important, recalling the point about the embeddings need to be compatible between your documents in the vector store and the user query that you are producing to fetch those top K documents. And here, actually, vector store, if we now look at the next task in our list, so I'm going to just fold this up. So the second task in our create knowledge base workflow is create search index. And it's actually going to take in the knowledge base. This is actually how you define a default argument that is basically an artifact. So you can pass in actually a list of documents itself, but if you just call this without passing any arguments, Union will understand, hey, just get the latest knowledge base that you have materialized and feed it into this create search index task. Again, details. The main one to look out for in this is, hey, we have an OpenAI embedding type and a Hugging Face embedding type. So OpenAI embeddings will be the kind of closed source, higher capacity, probably better quality embeddings, potentially. And then you have a model called All-Mini-LM L6v2. This is a much smaller model, much cheaper as well to embed using open weights. But other than this, we're using LangChain constructs to construct a FICE memory in-memory vector store, and we're writing this to disk. And actually, Flyte will handle writing this to a blob store and persist it up somewhere. You don't have to worry about that, actually. Yes, knowledge base and vector store, you can think of these as artifacts, as kind of like entities that have a type. So Pinecone would be a remote vector database that's a hosted solution that you make an account and it's persistent. This is literally just a file in a file system somewhere. And you can write it to disk, persist it on a blob store like S3. Yeah, exactly. And if we look at the task decorator here, there are some bells and whistles. Actually, not even bells and whistles, core fundamental things that help you develop production-grade apps. So the first one you'll notice is we're specifying a container image in both of these tasks. This means that in Union and in Flyte, all tasks run on their own container, meaning that these images can actually be different, but for convenience, we're using the same image definition, but they will run on their own container. And so if you've ever worked in a team and you're stepping on each other's toes with like versions of specific packages between tasks, this is a way for you to completely isolate those two tasks and have one version of PyTorch or Pandas in one task and then another version in another task without breaking anyone. We're also caching these steps, which is what I did, which is why when I ran it, it ran super quick. I can also request for specific sets of resources. Enabling deck allows me to create a Flyte deck, which I'll show you a little later. This allows you to visualize things that are happening inside your tasks. And a secret request in this task means that we're getting the OpenAI key that we just created. Okay, so if I go over to this knowledge base execution over here, I can, since these were cached, I'm actually going to click on this view source execution button here to show me where the original execution was that produced these things. And I'm going to just show you quickly, since I mentioned it, the Flyte deck. I actually haven't produced any specific visualization of the knowledge base or vector store, although I could have. But the default tabs under this Flyte deck show you the timeline view of how basically it's an automatic profiling of your task, how much time was spent executing user code versus downloading the data and uploading the data back to Blob Store. Source code of the task. It's pretty nice to see dependencies of the task in Python, and then inputs and outputs in very vanilla text format. Okay, so we have about 25 minutes left. The part I wanted to show you here about the image is, raise your hand in the chat. I don't know, do a little hand wavy emoji. If you are super confident in your Docker file building abilities, you can build a Docker file for whatever you need with very little reference to the Docker docs. If you're like me, I have a happy path, but I'll have to often look things up if things get difficult. So the way we've abstracted this away for you is with this image spec object. This allows you to specify your Python deps, your OS level dependencies, environment variables you want baked into your image. And this basically boils down to basically a Docker file that is then built for you on Union serverless. So you don't have to worry about that. Okay. So where are we at? So hopefully your knowledge base has been created. The next part is we're going to run a workflow that basically just implements this retrieval and generation step. So if we go down, there's a workflow here, a cell here that runs a workflow called ask. So I'm going to go ahead and run this. And this too shall produce a workflow. So this execution over here will actually run our RAG application for just one step. This will take about 30 to 40 seconds. I guess while we're here, I just want to show you how you can find an artifact on the UI, which is under this artifacts section of the app. And you can see the different materializations of the vector store and knowledge base that I've created over time. And this will give you a lot of things. It'll give you an auto-generated version. Yeah, we can get to the Docker step after. You can see the execution that produced this artifact. So you can trace it back to a particular execution. You can see how you can access this object. In this case, it will be a directory containing a vector store onto a Python session. Rebecca, to answer your question really quickly, image spec, which is this object over here, this basically is a specification that wraps a lot of the stuff you need, most of the things you need to be productive, at least in Python. So you can specify pip packages or conda packages with the conda channels, what version of CUDA and CUDA DNN you want, etc. And so you can think of this at a high level as compiling down or being transformed into a Docker file that is then built on Union. So, this, if I go to this execution over here, it is the image build workflow. So we're using Union and Flyte itself to do this. And let's see if there's some live logs here. Yeah, so this gives you logs. If you have some issues with your Docker build process, you can see what went wrong over here. So I got to that with this live logs link. Okay. So if I go back to this workflow here that I ran, it succeeded, which is good. And if we look at the outputs, if we remind ourselves, we just asked a pretty simple question: what is Flyte? This workflow uses GPT-4o, and it answers pretty well. Flyte is a Python SDK that allows for the development of Flyte workflows and tasks. We use the LangChain question answering pipeline with sources, so it actually gives us sources, and hopefully these are, oops. Okay, it keeps closing on me, but this looks like a valid URL. The last step we'll do, before we look at what this code looks like, is it's useful in a RAG app to be able to get some feedback. So we're going to run a workflow called Ask with Feedback. And what this does is, we'll just take a look at the graph view. So this sub workflow is essentially this answer question workflow, this ask workflow that we ran before, right? But as we'll see in the code later, we can have a workflow can be composed of tasks, but it can also be composed of workflows, which we call sub workflows. So you can arbitrarily compose these kinds of things, and we get an answer. In this case, it's slightly different maybe, but pretty much the same as the answer we got before. But it's waiting for feedback. So this is what we call a gate node. And you can imagine use cases for this that are not RAG or LLM related. Say you want to deploy a model and you want a human to inspect some metrics produced by this previous workflow. And then the human goes in, okay, let me thumbs up. In this case, this is just text, super unstructured. And it takes a few seconds for the feedback to get resolved. But that's how you can actually bake into your workflows, which are these DAGs right here. You can have a gate node as part of that DAG to stop execution or stop the progression of that workflow into the next steps until there's some human feedback. Okay, so I'm going to hop back into my VS Code editor and show you what that GPT workflow looks like. So our ask and ask with feedback workflows are pretty simple. They just have one step in them, or this ask one does. Ask with feedback has two steps, basically. It runs this ask workflow and then waits for input to get feedback with an expected string type. We introduce a dependency between these two with this close angle bracket syntax. And that's what you saw in the UI. Yes, Anoop, that was just for convenience to have your workflow run quickly. So usually you would run this with none and have the entire docs be ingested so that it can ask, or it can answer more questions. The answer question task itself, if we take a look at this, also uses an API key. And we're basically rehydrating our FICE vector store, in-memory vector store here with the OpenAI embeddings. As you can see, we are requesting a search index, which is a vector store with embedding type OpenAI. So this would fail if I requested for a Hugging Face vector store embedding type. We are then introducing a prompt template if you want to customize your prompts. I'll show that in the end. And the LangChain code here, is super nice. I mean, once you want to customize things, like maybe you can do pure Python or maybe use another framework, but I find LangChain to be super easy to use out of the box if you just want to get something working to get a sense of how your system can work. And if you use, actually we're using GPT-4 Turbo here. If you use the state-of-the-art LLM via API call, you can get pretty good results as kind of like a demo or prototype. But the LangChain specific syntax is we're creating a chain of question answering chain that produces sources. We then invoke it with our index saying that, hey, we want the top 8 similar documents relating to this question. And then finally the question. And what you get out is simply a string for the output text. Anoop, I will circle back to the feedback in the next section of this. I think that's all I wanted to show off here. But as you can see, this is a fairly simple step. And if you wanted to bring your own code to implement your own RAG pipeline, you can implement that in Python in your own private package, and then just import them here in the task. Okay. So this next step is optional. You can probably run through these steps yourself on your own, probably after this workshop. But I'm going to share a link on the Slack. Let's see if I can post it on chat, actually. But I'll post it on both. Okay. So I just posted a Streamlit app link onto the Slack channel. And again, as I mentioned earlier, Union is currently not built for super low latency workflows. It's optimized for batch workloads. But to give you a sense of how this works and how to interact with a workflow and task you've built, let's ask, can you explain what Flyte does well as if I'm 5 years old? And this is going to take 30-ish seconds. But as we wait, we can actually go back to the dashboard. We can go to our executions and see there is an execution here that was kicked off about 9 seconds ago. This is literally the one that's associated with this. And I'll show you the Streamlit code. It's fairly simple. So it's about 100 lines-ish of code, well, 140. But the way you call Union workflows and tasks from a completely different system is through this object called Union Remote. And once you've defined this, you can fetch a workflow. So here we're fetching ask with feedback. You can also execute that workflow with a question. So the Streamlit app itself, I won't go into the Streamlit specific code. You can take a look at that later. But this is basically asking the question and, oops, did it already? Oh, yeah, wrong workflow. So yeah, I think maybe some of you are asking these questions, and so there's a bunch of executions here. Let me see if I can find my original one. Okay, I think this is the one, but it's paused. So Anoop, going back to your question, to provide feedback, there's a button here on the list view or a button here in the graph view that's like a play button. And this lets you provide the text input. But actually, I've hooked this up to the Streamlit app itself, so I can give a thumbs up here. And this will actually send that feedback up back into the workflow to complete it. So feel free to run this on your own fork of Union RAG and on your own account of Streamlit. You basically just have to follow these additional steps to create an API key, a Union serverless API key. But then everything should just work out of the box. With 10 minutes left, I did want to leave 5 minutes for questions. So the last part, unfortunately, we don't have a lot of time to talk through this, but I'm just going to rapid fire run these workflows. And these should be cached for me. But I'm running a workflow to create another knowledge base with a Hugging Face embedding type so that it can work with this open weights Hugging Face model. And then I'm creating a workflow for asking OLlama. So what this does is it will, on the task container, it will create an OLlama server and use Llama 3, I think billion, to then answer the question. And this actually will produce a very bad answer because the default template that LangChain ships with, I think, has some like few-shot learning examples that relate to answering questions about like US history or something. It's kind of weird. Is this? Okay, this is waiting to build. But I can actually run the same exact Ask OLlama workflow with a custom prompt template. And this will actually give me a much better answer. So just real quick, the delta, oops, wrong. So I'm back in the LangChain.py file. Let me find this. So the delta between the GPT, the workflow that used GPT versus the one that did not, or that uses OLlama, is basically that I'm using Hugging Face embeddings to embed the query to fetch the top K documents. And then I'm using this chat OLlama class here with the OLlama model name, which is Llama 3. And I've done some magic here with a decorator to start the OLlama server in the task container. So it spins up a server with OLlama serve. It has Llama 3 8 billion preloaded into the container. And the code, the LangChain code is pretty much exactly the same, except you swap out the embeddings and the LLM that you use for retrieving and generating. Or sorry, for generating. And this custom prompt template I actually fed in through the command line here. I basically took the LangChain. So yeah, the LangChain default prompt template is like, question, what states, countries, law governs the interpretation of the contract? And then you have some sources, you have some final answer. So I basically took this and took out all the few-shot learning examples, and then I changed this kind of system prompt to be, hey, you're a helpful Flyte chat assistant and expert in Flyte and Flytekit. So this is like step one in the RAG iteration cycle is, before you fine tune, before you do all this stuff to like update the weights of your underlying LLM, you should just try to optimize this against some evaluation data set, which is a whole topic, it's a whole other can of worms for another workshop. But assuming you have some kind of metrics, evaluation metrics for the RAG system as a whole, you can then start twiddling around with this prompt to then try to get it to produce higher quality results. Okay, so let's see. Just for completion, I'm going to run this last one. I'm going to just show you the default prompt template. It's running. So this will actually take a long time. So I just want to highlight like we are working on certain capabilities to actually make this a lot faster, closer to like 30 seconds. But this will first provision a node. So this will provision a T4 GPU, single instance of a T4 GPU, which I can actually ask for declaratively. Just one GPU with so-and-so memory and CPUs. So it'll provision that GPU first, spin up the server, run the user code, and then return. So we're actually working on a cool thing that I want to show you maybe in a future workshop, where this container stays alive, and so you can keep sending workloads to the same container, so you don't have to like incur this entire like cost of spinning it up and doing all this other stuff. Cool. So just to wrap up, I'll answer some of the questions in chat. In conclusion, we've set up a serverless account. We've run a RAG workflow with LangChain and GPT. We saw how it was like to actually integrate some other third-party application to Union serverless. We swapped out our closed source models for open weights models. This should be Llama 3, not Phi 3. And we saw just a real quick way of improving or iterating on the entire system just by changing the prompts. And if you're curious, there's a bonus thing here if you want to learn how to integrate this onto your Slack channel, for example. And the README for that is here. So again, thank you so much. I'll stick around and answer the questions until the top of the hour. So Rebecca asks about data flow. Question about the data flow from user query through to the LLM in response. Would you recommend a quality check for the results from the response back to the user? This is definitely one way to do it. I mean, that is kind of a human in the loop step that you could implement with this gate node concept. Again, if you didn't care about latency, if you had a chat assistant where the user can come back in an hour or something, and you want a human expert to vet and edit and even override the answer, that's definitely something you can do on Union natively. And that is actually a good source of labels too. Labels in the sense being like a ground truth of what an expert response would be. Charles asks, did we need to change our collab runtime to TPU? No, so this request right here, this happens on Union. So if I hop onto this actually is running on a GPU. Not sure if, so you can actually see resource utilization metrics here, but it's not running long enough to be able to visualize this currently. This is usually for workloads that run for at least 5 to 10 minutes. What types of GPUs are available in Union? So right now, T4s, we are getting our hands very soon on A100s. And also, I think L4s, I need to double check on that. But as you all might know, there is a huge demand for GPUs. So we are slowly going to get access and give access to our serverless folks to those GPUs. There's a lot of cool stuff we can do with that too. So we can leverage GPU partitioning. So if you have an A100 with 8 GPUs in it, you can actually have 8 different users use one GPU in that 8 GPU node. Anoop asks, how long does Union save previous execution results for? These will be persisted. So it's on Blob Store. They are persisted. So you can use them pretty much forever. Okie dokie. We have 1 minute left. Again, thanks so much. Hope you learned a little something about RAG and LLMs, and then also Union. So you can try it out today. If you've gone through this workshop, you have an account already. We are in our public preview stage. We're iterating super quickly on this. So yeah, if you are interested, you can circle back onto the Flyte channel. I'll actually follow up on LinkedIn and other channels where you can go to ask questions if you continue to use serverless. And yeah, we'd be happy to get your early feedback and shape the future of this product. Oh yeah, thank you, John. It is 30 days. So that is our retention policy. I wasn't aware of that for execution results.